relative velocity method, and today we will discuss what is the instantaneous center and how we locate this instantaneous center and all these things, okay, and how we obtain the velocity, or how do we do velocity analysis by using instantaneous center. Okay, so first of all we will try to understand what is the instantaneous center. So for that, actually I'm considering a body here. Suppose this is a body, okay, the body is P, okay, the body is P here, and the P is having a relative motion on another body P, Q, okay. So PQ are bodies and they have a relative motion, okay. So now here actually I'm considering one point here, one point A, okay. A is a one point on P, and here if you understand the velocity of this one is like this, okay. I am assuming that the velocity of a point A on the body P is VA in this direction. So that actually once if you know this one, okay, the direction of this the point A velocity, the body P can rotate about the line. If you draw a perpendicular line to this, okay, the body can rotate about this point, about any point on this line, okay. So now here this we know, okay. So I'm considering another point B here, okay. This is the another point B, and suppose this is the velocity of the point B here. And now if you draw this another perpendicular line, okay, so this is a perpendicular line here. So if you draw a perpendicular line, the body P can rotate about this line, okay, this any point on this line. So now we are considering 2 points here. So now the body P can rotate about the intersection of points, this, okay, about this is the intersection point. This we call as a instantaneous center. That means the body P can rotate about this I, okay. I is the instantaneous center, okay. I is the instantaneous center, precisely it is velocity, okay, instantaneous center of velocity, okay. So now here suppose here there is a body P here and another body Q here, okay. And now what will happen, suppose actually the body here, the instantaneous center of P and Q, okay, is lie on the body P. Suppose the instantaneous center may be outside of the body also, okay. Suppose this is a A point and this is a B point, okay, and this is VB, and if you draw a perpendicular lines, okay, it is outside of the body P. That means actually the instantaneous center for this condition is on the Q body, okay. In this case the instantaneous center is on the P body. So instantaneous center can be on the body or outside of the body. It may exist on the outside of the body. So the meaning of instantaneous center is the body can rotate, okay, about the instantaneous center, okay. So in one case I am considering here the body here, one body P and another body Q here, and now suppose this is A point and the velocity, okay, the direction of the velocity of point A is in this direction, okay, in horizontal direction. So instantaneous is like this, okay. Instantaneous center, if you draw a perpendicular line like this, that means the body can rotate about this point, okay, this any point on this line. And if you take point B here, and this, the velocity of point B is in the horizontal direction, so this is a perpendicular line. Okay, so now what will happen here? The two lines are not meeting, okay, not intersecting each other. So I, you can say it is at infinity. Okay, the meaning of the instantaneous center of body and P and Q are at infinity means the body is not rotating. Okay, the body is in the body P and Q. P is pure translation. Okay, the body P is relative to Q, the motion is pure translation, because the I is lying at infinite. Okay, so like this we can understand these things. Okay, the instantaneous center. Suppose the notation for the instantaneous, normally we used to look at IPQ. Okay, IPQ. The P represent the body, okay, the P relative to Q. Okay, so suppose if 1 2 is I1 2 is one instantaneous center. Okay, so normally we will represent I1 2. Okay, normally we will represent in ascending order of the numbers, ascending order of numbers. Okay, like this we will represent. Okay, and now we will try to understand one more thing. Suppose actually the number of eye centers. Okay, we can calculate the number of eye centers. Number of eye centers. Suppose capital N is the number of eye centers, instantaneous centers, and suppose in small n is a number of links. Okay, number of links. So number of eye centers can be calculated like n into n minus 1 by 2. Okay, n into n minus 1 by 2. Suppose if n is equal to 4, that means in a 4-bar mechanism, okay, in a 4-bar mechanism, actually you can calculate the number of eye centers as 4 into 3 by 2. So that means 6 eye centers. Okay, there are 6 number of eye centers will be there in a 4-bar mechanism. So the number of eye centers we can calculate by using this equation. So okay, so actually this instantaneous centers are we can locate at a particular instant, because actually if the body is rotating, the instantaneous center also rotating. So we will locate the instantaneous, whatever whatever the mechanism, whatever may be the links, number of the links. So we will locate the eye centers for a particular instant. Okay, for a particular instant, because the body is rotating, the if there is any relative motion between the bodies, the eye centers also can change. So we will look at the eye centers at a particular instant. Okay, and also actually the important thing, okay, the interesting thing here, when we look at the eye centers, okay, the eye centers can be on the body or outside the body. We can easily identify. Okay, we will look at, okay, we will discuss another theorem to look at the eye centers. Okay, so the eye centers may be on the body or outside of the body here. And one thing here, actually, as the body, suppose if you take this example, as the body P rotates, okay, about the eye center, okay, I here, so you can look at IPQ. Okay, so this is the IPQ. Okay, the meaning of IPQ is nothing but the body P is rotating about this point relative to Q. Okay, that is the meaning. Okay, so now what is the velocity, at eye center? Okay, what is the velocity at the eye center? Because we know that v is equal to r omega, so actually the velocity is proportional to the distance. Okay, r, okay, the distance. So now the velocity at the eye center, because the radius, okay, that means the distance is 0, so you can say that at the eye center the velocity is 0. Okay, at the eye center the velocity is 0. That means actually you can say that at a particular instant, okay, at this particular instant the bodies are at rest. Okay, relatively at rest. Okay, you can say that the body P and Q are relatively at rest at this instantaneous center. Okay, and also you can say that there is no relative motion between the bodies at eye center. Okay, that means actually the you can say that at, because the radius, that means the distance is 0 at the eye center, you can say that the body and P and Q are relatively at rest, or otherwise you can say that there is no relative motion between the two at the eye center. So these are helpful in doing the velocity analysis, and in this way we will calculate the number of eye centers and the location of eye centers. Okay, now actually we will try to understand how to locate the eye centers by using Kennedy's theorem.